We are doing GCE O-Level 2014 A-Maths Paper 2, question 10. In this question, we are given the equation of a circle. From this equation, we are asked to find the radius of a circle and the center of the circle. To do this, we have to express this equation of circle into x minus a square plus y minus b square equal to r square, where the coordinate AB give us the center of the circle and the r value give us the radius. This is shown in this diagram where AB is the center, r is the radius, xy is any point in the circle. To express this equation into this form, we have to complete the square for this equation. Now I'm going to introduce the formula for completing the square. If we have a quadratic expression x squared plus kx, we can complete the square by using this formula. X plus k over 2, k is the coefficient of x, the whole thing square, minus away k over 2, whole thing square. Let's apply this formula to complete the square for the variable x. So if I were to complete the square for this variable x, I need to identify the k first. The k is beside the variable x, so k take the value of 4. So x squared plus 4x can be rewritten into this expression here. X plus k over 2, k is 4, 4 over 2 whole thing square minus k over 2 square, 4 over 2 square. So again, k take the value of 4. Now I'm going to complete the square for the variable y. So this is a y square minus 6y. The k for this case will be negative 6. K is always beside the variable x or y. So now the k is negative 6. If I were to complete the square, it will be y plus k over 2, y plus k. K is negative 6. Don't forget about the negative sign. Negative 6 over 2 square minus negative 6 over 2 square. The whole thing is equal to 36. Let us simplify this expression. X plus 2 square minus 2 square is 4 plus y minus 3 square minus 3 square is 9 equal to 36. Now I'm moving a constant to this side of the equation. 36 plus 9 plus 4 will give us a 49. This value here I need to express into a perfect square so that I can get the radius. Now this expression here matches this form, so we can get the center of a circle and the radius of a circle. The center of the circle is at the coordinate AB. Okay, notice this is a negative A and negative B. So for this case, the A will be negative 2. So it's negative 2 and 3. You have to put a negative to this value and to this value to get the value of A and B. The radius is actually 7. Now we are doing question 10 part 2. For question part 2, it's good that we draw the diagram out. It will help us to understand the question better. Now the question says this circle C2 has a diameter AB. So I mark a point A here, then B will be here. So this is a diameter of the circle, and we are told that the point A has the coordinate minus 5, 5. And we are told that the tangent at B, let's draw a tangent at B. The equation of this tangent is 3y equal to 4x minus 15. We are asked to find the equation of this AB, of this diameter line AB, and find the coordinate of B. To find the equation of this straight line, we need two things. First is the gradient. Second is a point. And for this case, we know the coordinate A. So we use A as a point. For gradient, the gradient of this straight line we don't know. But we know that this is 90 degree because this is a diameter and this is a tangent to the circle. So this is 90 degree. That means the gradient of this straight line multiplied by the gradient of this line here AB must give us a -1 because they are perpendicular. So let's find M1 first, which is the gradient of this line. After you find M1, we can find M2. Let me express this equation into y equal to mx plus c form. So y will be 4 over 3x minus 15 over 3 will be 5. So y equal to mx plus c. Therefore, m1 will be equal to 4 over 3. And we know that m1 multiplied by m2 equal to -1 because these two lines are perpendicular to each other. So m2 will be equal to the value of m1 is 4 over 3. So -1 divided by 4 over 3 will be -3 over 4. Therefore, equation of AB is given by the gradient formula y minus the coordinate y here, which is a 5, x minus the x coordinate here is a -5, equal to -3 over 4. If we cross multiply, it will give us this expression here. So if we were to simplify this expression, it will give us 4y plus 3x is equal to 5. That is the equation of AB. So now we know that the equation of AB is 4y plus 3x equal to 5. Now we are asked, the next thing we are asked to find is the coordinate of B. The coordinate of B is the intersection between this line and this line. So we just need to solve a simultaneous equation of this equation and this equation. The solution will be the coordinate of B. I've written down the two equations here. The solving part I will run through quickly. For 10 part 3, we are asked to find the radius and the coordinate of center of C2. To find the radius, we need the coordinate A and the coordinate B. The coordinate of B is, we find out from 10 part 2, 3, -1. To find the radius, what we can do is we use the formula of distance to find the diameter first. Then we divide the diameter by 2, it will give us the radius. So the distance AB is given by the formula y2 minus y1 square plus x2 minus x1 square. I can call this coordinate x1, y1, x2, y2. So y2 minus y1, negative 1 minus 5 square plus x2, 3 minus 5 square. Square root this expression. It will give us 36 plus 64. So the diameter will be 10. Therefore, the radius will be given by 10 divided by 2 will be 5. Now we're going to find the center of this circle. The center of this circle is actually the midpoint of AB. The formula for the midpoint is x1 plus x2 divided by 2, y1 plus y2 divided by 2. It will give us x1 negative 5 plus 3, and 5 plus negative 1 divided by 2. So the center will be at negative 1, 2. For question 10 part 4, we are asked to explain why the point 46 lie in one of the circle only. To do this question, we have to understand how to test a point P is inside or outside a circle. Let's say we have a circle and we know that the coordinate of the center of circle and we know the radius. And let's say we have a point P. Okay, how to know that P is inside or outside a circle? What we can do is we can find the length from P to the center of the circle. If this length right is greater than the radius, we can say that the point P lie outside the circle. If the value of L is smaller than the value of the radius, we know that this point P lie inside the circle. From the previous question, we know the center and the radius of the two circles. Now we are going to find the length from the point 46 to the center of the circle. The formula of length is given by y2 minus y1 square plus x2 minus x1 square. This will give us the value of square root of 45, which is equal to 6.71. And 6.71 is in fact smaller than the radius 7. Now we know that the length from 46 to the center of a circle is 6.7, which is less than the radius 7. So we can conclude that the point 46 must lie inside the circle. Okay, length is less than the radius. So we can conclude that 46 lies inside the circle C1. Now we're going to find the length from 46 to the center of C2 is y2 minus y1 square plus x2 minus x1 square. It will give us square root of 41, which is 6.40, and 6.40 is greater than the radius 5. So now we know that this length here, 6.4, is greater than the radius 5. So we know that the point 46 must lie outside the circle. The point 46 lie outside the circle C2. To conclude, since the point 46 lie inside the circle C1 and point 46 lie outside the circle C2, therefore the point 46 lie in only one of the circle.